Hello, my dear students. Let's continue. The first thing I want to do today is to correctly spawn the character at the beginning of the game. Right now, it appears on loading just like all the other objects. Let's disable its default spawning. And after loading, we'll add it to the scene using code. Select the cube, go to the object's properties, and in the Armory props section, uncheck the spawn checkbox. Now, if we run the game, the character won't appear in the center of the field or anywhere else. This object doesn't exist yet. Let's go back to the scene and move the cube aside. Its position doesn't matter now. Now, let's switch to the logic node editor and create a new logic branch. To do this, close the current one by clicking the cross icon. It won't disappear. You can bring it back on the screen at any time by opening the list of existing branches. So, click the New button. Let's name the new branch Game Init, of course, with a capital G. In this branch, we will gather all the events that will be processed at the beginning of the game, and the appearance of the character on the scene is one of them. We can't attach this branch to the cube because it doesn't exist at the start of the game, so the code won't execute. We can, for example, attach it to our background, which is called ground. Select it, go to the object's properties, in the Armor Traits section, create a new slot, and add the Game Init branch to it. Now, let's create a new block. It can be found in the Events group and is called onInit. Anything we attach to this block will be executed once, without repetition, right after the object is loaded into the scene. In other words, as soon as the game starts, our background will appear on the scene and execute this chain of code. All we need to do now is spawn the character. Get a new block. Spawn object by name. And connect them. In this block, we need to specify the scene's name, which you can find in the list of scenes at the top right. You don't need to retype it. You can simply select it from the list. In the name field, we must specify the name of the object we want to spawn. Here you will have to type it manually. To avoid making mistakes, you can select the cube, press F2 to copy its name to the clipboard using Ctrl+C, press Escape, return to the logic editor, and paste the name into the block using Ctrl+V. The last thing we need to specify is the spawn coordinates. We must connect them to the transform channel. You can do this, for example, using a transform block from the variables group. The transform block includes all transformations. We will leave rotation and scale unchanged, but we need to specify the coordinates. The cube should appear in the center of the screen, so we'll leave zeros for the X and Y axis. However, for the Z axis, we need to change it to 0.5 because that's the height at which our cube is located. If we leave it at 0, the cube will sink into the ground up to its waist. Save the project and run the game to make sure the cube is back on the screen. If everything is in order, let's add a delay before it appears. Get the sleep block from the miscellaneous group and drop it directly onto the wire between the two blocks. It will automatically connect between them. Let's introduce a delay of a couple of seconds and see how the character's appearance looks now. It seems more appealing. Let's move on. Now, let's talk about the character's speed. In my opinion, the speed is too low, and I want to change it. What do we need to do for that? To do this, we need to go to the player input branch and change the values in 4 different places. However, this is not very convenient and, one might say, incorrect. This is because later on, we will need to change the speed dynamically, right in the middle of the game. For example, after drinking a cup of coffee, the character will accelerate. To implement this scheme, we'll need a variable to store the current speed value. Select the cube, go to the object's properties. In the Armor Props section, find the Properties window and click the plus sign to add a new variable. Since the variable will store fractional values, choose Float from the menu that appears and click OK. Let's name the variable Speed. According to naming conventions, variable names typically start with a lowercase letter. Let's set the value to 0 whole 100th. Now, let's assign this variable's value to the movement blocks. Open the player input branch and retrieve the getObjectProperties block from the object group. This block returns the value of the selected variable. Leave the object field empty because the branch is linked to the cube, so the variable's value will be requested from the cube. However, you need to copy the variable's name and paste it into the property field. Let's take a moment to talk about copying. To copy a property's name, there's no need to double-click it and then select the content while holding down the mouse button. No, all of that is unnecessary. Just hover your cursor over the property name and press Ctrl+C. You can be sure it's copied. The variable's name is now in your clipboard. Now, to paste it into a text field, you don't need to click on it with the mouse and insert the cursor for editing. Just hover your cursor over the field and press Ctrl+V. That's it. Pretty cool, right? Now, let's think about how to connect the obtained value from our variable to this blue input called vector. The thing is, the vector channel consists of 3 values, corresponding to the 3 axes, x, y, and z. But in our variable, we have a regular decimal value. If we directly connect it to the vector channel, it won't lead to anything good. If we carefully look at this block, we'll remember that for moving forward, we specified the speed only for the y-axis. That's our task. We need to take the value of the variable and connect it separately to the y-axis. For this, we need another block. It's in the variables section and is called vector. Now, we take our variable and connect it to the y-axis. Next, duplicate the vector block and connect it to the backward movement. Don't rush to connect the variable. Let's remember what value we use for moving backward. It's negative. If we connect the variable like this, both the forward and backward keys will work the same way, and the character will only move forward. In this case, math comes to our rescue. We just need to invert our variable by multiplying it by -1. Get the math block from the math group. Insert it between the variable and the vector. Set the block to multiplication and multiply the variable's value by -1. Now, when we press the S key, the y-axis will receive the variable value multiplied by -1, and the character will move backward. Let's test this by running the game. Great! We need to do the same for left and right movement. For the A key, we'll use the inverted value for the x-axis. And for the D key, we'll directly connect the variable's value to the x-axis. Don't forget to connect all the cables from one vector to the other. By the way, those blocks with console output are no longer needed. You can delete them. Run the game again and test all the keys. If all directions work correctly, you've succeeded. If something went wrong, it means you made a mistake somewhere. Go back to the editor, check all the blocks, connections, names, and values. As a last resort, don't be afraid to start from scratch. At this stage, it's not a big deal, and repetition will deepen your understanding of the processes. So, what do we have now? If I want to change the character's speed, I only need to modify one value stored in the variable attached to the cube. Just input the new value, run the game, and see the result. Now you can take a break. Don't try to tidy up this mess. We'll start with that in the next lesson. I'll show you some tricks that will greatly simplify your life. Take care. Goodbye for now.